Hi everyone, this is your second lab. It is Introduction to Scientific Writing and Creating Tables and Figures according to the format from the Council of Science Editors. This lab will get you ready to develop the tables and figures that you will put into not only your laboratory sheets, but also your 2 laboratory reports that you'll write up. So we're going to go over the important areas of this file, and then you can always look at the format in your learning module. Learning objectives for this lab. You're going to be learning about the steps of the scientific method. You're going to understand the parts of a scientific paper and how to prepare tables and figures for that paper. And then you're going to analyze a scientific paper and some of the data in it. So let's get started. When we talk about the scientific method, we're talking about the manner and the sequential steps that are used to solve a scientific problem with evidence. There are 6 steps in sequence for the scientific method. First, there's an observation, and the observation is of the natural world and usually poses a problem that needs some research and some exploration. Then there's a hypothesis, which is a possible explanation for what's going on with the problem. Third, there's experimentation or testing that is done to collect data to see if the hypothesis can be supported. We'll get into that. Fourth, the data is laid out in a data collection section. Fifth, the data is analyzed, very different part in very different section. First you collect the data, and then later you analyze it. We'll talk about that. And finally, there are conclusions that are drawn on the basis of the analysis of the data. Let's go through each step one by one. When it comes to the observations, you can investigate prior literature. You can investigate a phenomenon with your senses. You can observe a phenomena with scientific and laboratory equipment. Basically, you're looking for something that piques your interest. And from there, researchers like you formulate questions to try to get to the causes of that phenomena. So when we look into that, when we look for the causes for what we're seeing or noting, we try to come up with an explanation for those causes. That explanation, that tentative explanation, is a hypothesis. It's based on the observations that you make and then the research that you do about those observations. In general, you make the observation, you think there's a problem there, you go and do research to see what others have postulated in the past. When you write out this explanation, you write it out as an if-then statement. Very important. You generally look at ifs as scientific laws or scientific theories or scientific facts. I like to put 3 if statements going from very broad to very narrow in each of my hypotheses. This if statement that you have here is a simple one. If antibiotic B works better than antibiotic A, then patients taking antibiotic B will exhibit smaller ulcers at the end of the study. If is always based on facts or theories or scientific laws. These hypotheses, these if-then statements, have to be testable. And you can see that you can measure the size of the ulcers before the study and after the study. But the hypotheses also must be falsifiable. In other words, those measurements may not be smaller at the end of the study. The hypothesis may not be supported. It may be refuted. The hypothesis must be falsifiable. Third step, experimentation. Now that you've made the hypothesis statement, now you've got to test it out. The goal is to supply evidence or data that pertains to the hypothesis. Sometimes the data supports the hypothesis, sometimes it does not. The design of your experiment is a list of all materials and a numbered list of all methods that you're using in sequential order, such that someone else could presumably repeat your experiment and get data that is very similar to your own data. When we design the experiment, variables are a critical part of the design. And variables are factors that impact cause and effect, which is exactly what we're looking for when we have an observation of a problem and we have questions about its cause, and we have a hypothesis that is looking at a possible explanation for the cause. Variables are the factors that produce cause and effect. There's several different types of variables, and it's important to understand the difference between the types. Controlled variables are factors that do not change during the course of the experiment. Oftentimes, these factors are things like the mass of food that we give to animals during a study. Or it could be the dosage of a medication that we give to pediatric patients. Or it could be the composition of soil that we're using in a field. These factors don't change during the course of the experiment. Now, you could change those factors. You could give different mass to different animals during the course. You could give different dosages of different medications during the course of the experiment. But in this case, you have chosen not to in these particular controlled variables. They differ for every experiment. And that's kind of the art of putting together an experimental design. Second type of variables, independent variables. Those are factors that are changed by the researcher, you. You decide when and how to change those variables. It could be that you change the temperature at which the animal eats the food. Maybe some animals get a very cold laboratory setting where they have their food, and some might get a room temperature setting, and some might have a very hot day when they eat their food. You change the temperature. You might change the time when you deliver a medication dose. You might change the type of fertilizer on that soil. Those are independent variables that you decide to change and that you note in there. And there are dependent variables. And the dependent variables are the factors that change as a result of things that you changed in the independent variables. So in other words, if the dog ate their food in a very hot room, I recognize there it says volume of sweat. Maybe you say volume of saliva produced, because we know that dogs salivate more to cool their bodies when they're hot. Okay? So you would be able to measure that volume. and that volume would depend on the change in temperature that you produce with the independent variable. Blood sugar levels can change on account of the time that you took the stick, the blood stick. So blood sugar levels can be a dependent variable based on the time that you chose for that data collection. The number of fruits, number of strawberries produced in the field could change as a result of the independent variable, the fertilizer type that you changed earlier. In a great experimental design, you're changing one independent variable at a time. For instance, you would not change the fertilizer type and the seed type at the same time, because then you don't know if the cause and effect is due to the fertilizer type change or the seed type change. So great studies change one independent variable at a time. Now, your study should also have control groups. Difference between controlled variables and controlled groups. Controlled groups are not exposed to the independent variable. It's a tough concept, and we'll get to the description of the concept in an example in just a second. But control groups are not exposed to the independent variable, and there are positive control groups and negative control groups. And the best way to go over this is to give you an example. Positive control groups are control groups where you expect a change. Negative control groups are groups where you expect no change.